welcome to the course of Data Communication and Networking, BE 7th semester Electronics and Communication. Up to the last lecture, we have discussed the overview of OSI reference model. We are discussing the introduction of data communication and networking, Unit 1. Today's session is based on the layers in the OSI model. We are going to see the OSI layers in detail in each and every layer. So let's start. So the first layer, as you can see in this figure, it is a physical layer. Physical layer is responsible for a data transmission in the physical medium. It figure shows that it will be any type of Ethernet cable. It have a Ethernet hub. It have a repeaters. The link may be wire, wireless, or optical fiber. So let's define the physical layer. The physical layer coordinates the function required to carry a bit stream over a physical medium. It deals with the mechanical and electrical specification of the interface and transmission medium. It also defines the procedure and functions that physical devices and interfaces have to perform for the transmission to occur. Means we can say that it is the layer responsible to transmit our data in a physical medium. As you can see in this figure, the position of the physical layer with respect to the transmission medium and the data link layer means a data will come from the data link layer. It will be converted in this physical layer in a bit stream or a stream of bits. Then it can be converted to the medium. According to the type of the medium, it will transmit the data at the receiving side. The physical layer at the receiver receives the data, decode it, and send to upper layer, just like our data link layer. So it is very easy to understand via this figure. So we can say that a physical layer is responsible for movements of individual bits from one hop node to the next. Means one computer to the another computer in our network. So it is just brief idea of physical layer. So what are the roles of the physical layer and what are the responsibilities of the physical layer? So we can go through. The following are the responsibilities of physical layer in our OSI model. So first is physical characteristics of interface and medium. In this here, the physical layer defines the characteristics of interface between the devices and the transmission medium. It also defines the type of transmission medium. Fine. Second, representation of bits. Representation of bit in the physical layer data consists of stream of bits, sequence of zeros and ones with no interprotection. To be transmitted, bits must be encoded into signals, electrical or optical, and physical layer defines the type of encoding, how zeros and ones are changed to a signal. Encoding, decoding, we are also going to see in our preceding sections. So don't worry about encoding and decoding. You just remember our representation of bits will be encoded in our physical layer. Third is data rate. The transmission rate, the number of bits sent each second, it is also defined by the physical layer. In other words, the physical layer defines the duration of bits, which is how long it lasts. Means you can say that it is one type of a speed of data transmission. Next is synchronization of bits. The sender and the receiver not only must use the same bit rate but also must be synchronized at the bit level. In other words, the sender and the receiver clocks must be synchronized. Means a particular sender and a receiver have a same data rate or a same synchronization of bits. If sender have a higher bits and the receiver have a lower bits, so it cannot be synchronized each other. So both have a same bit rate. That's why the synchronization of bit is required. Next is LAN configuration. The physical layer is concerned with the connection of devices to the media. In a point-to-point configuration, two devices are connected through the dedicated link. In the multi-port configuration, a link is shared among the several devices. Means it is just type of a link sharing. In a shared system, the link is shared among the different nodes. In the dedicated, entire link is given to the nodes. So LAN configuration is just type of connections or allocation of channel. Next is physical topology. In the physical topology, defines how devices are connected to the MAC network. Just like we have seen our previous sessions that different type of topology are used to define a particular network, just like a star topology, mesh topology, ring topology, bus topology, or a hybrid topology. I think you have brief idea about each and every topology, so we are not discussing each and every topology right now. Next is transmission mode. The physical layer also defines the direction of a transmission between the two devices, simplex, half duplex, or full duplex. As you know, in this type of a transmission mode, simplex, half duplex, and full duplex each have a different characteristics. In the simplex mode, only one direction communication can be possible. Suppose one node is transmitting and another node is receiving. In the half duplex, the direction of the transmission can be both, but at the same time only one direction is possible. Means a transmission 1 can be transmit at the time of T1, at the same time node 2 is only listening or receiving. At time t is equal to 2, node 2 is sending the data. At that time, node 1 is only receiving the data. So it is a bidirectional but not the same time. In the third mode, full duplex. In the full duplex mode, two devices can be send and receive the data at the same time. These three you have already learned from our previous sessions. So it is a just roles defined by the physical layer. It is very useful at the initial stage. Second layer means the layer number 2, name is data link layer. As you can see in this figure, the data layer is a one type of a frame, means it can deal with a frame. The data link layer transfers the physical layer a raw transmission facility to the reliable link. It makes the physical layer appear error free to the upper layer, network layer. Means it can give the data error free to the upper side of the layer for the network layer. This figure shows the relationship of the data link layer to the network layer and physical layer. Means data comes from the network layer, our data link layer convert into the frame and then gives to the physical layer. At the receiving side, data collected from the physical layer, frame analysis done by the data link layer, and the data given to the network layer. You can see in this figure that it is H2 data and T2. H means header, T2 means trailer. Same thing is at the receiving end. The detailed structure of the frame structure we are going to see in our preceding sessions or the next chapters. So we can say that the data link layer is responsible for moving frames from one node to the next. In the physical layer, we are dealing with the bit stream. In the data link layer, we are dealing with our frames. Fine. So remember this thing. Each and every layer responsible for some transmission method. So let's see the roles and responsibilities of the data link layer. So Responsibility of the data link layer is following. First is framing. The data link layer divides the stream of bits received from the network layer into the manageable data units called as a frame. As I already told you, that frame deals in the data link layer. So it is responsible to manage the frames. Second, physical addressing. If the frames are to be distributed to the different system on the network, the data link layer adds a header to the frame to define the sender or the receiver of the frame. If the frame is intended for the system outside the sender's network, the receiver address is address of the device that connects the network to the next node. Means, as you can see in this figure, the header contains the source address and the destination address. If the destination address is not in the predefined network, it have a particular address to route the data or to direct the data where our particular frame can reach its receiver. Fine. So it is a header, it is a trailer. Next is flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which the data to be produced in the sender, the data link layer improves the flow control mechanism to avoid the overwhelming the receiver. Means a matching must be required. At which rate the data is generated, which is nearly equal to the data can be received at the receiver. So flow control is required, and it is responsibility of a data link layer to control the flow of data. Next is error control. In the data link layer, the error control is one of the major thing to be considered. The data link layer adds the reliability to the physical layer by adding the mechanism to detect and retransmit the damages or lost frames. It also uses the mechanism to recognize the duplicate frames. Error control is normally achieved through a trailer added to the end of the frame. As you have seen in our frame structure, a particular trailer is used to control the error, in which particular format is defined that if particular error is occur, it can be detected at the trailer or a trailer. Then it gives the message to retransmit the data or lost the frame. Next is access control. When two or more devices are connected to the same link, the data link layer protocols are necessary to determine which device has to control over the link at any given time. Means a particular sharing link is given, then at which time a node use the link and at which time it release its link to use that link to the another node. Means access control is done by the data link layer. Yes. Following figure illustrates the hop-to-hop or node-to-node delivery by the data link layer. Suppose sender A wants to send the data to the F. So how our transmission can be done? As you can see in this figure, the communication at the data link layer occurs between the two adjacent nodes. To send data from the A to F, three partial deliveries are made. First, the data link layer at the A sends the frame to the data link layer to the B via a router. The second, the data link layer B sends the new frame to the data link layer E. Finally, the data link layer E sends the new frame to the data link layer of the F. Note that the frames are exchanged between the three nodes have a different value of headers. The frames from the A to B has a destination address and A has a source address. The frame from B to E, where E has a destination address and B has a source address, and the frame from E to F, the F has a destination address and E has a source address. The value of trailers can also be different if the error checking includes the header of the frame. Fine. So it is very easy to understand the diagram of a data link layer hop-to-hop delivery. So what is the next layer? First is physical, second is data link, third is, yes, network layer. So what is the network layer in our OSI model? As you can see in this figure, there are some key points written over there, just like IP address, formats of the data in packets, destination address, source address to the lower address. Fine. So it is one type of a delivery of a packets. Let's see in the technical term. The network layer is responsible for source to destination delivery of a packet, possibly across the multiple links. Whereas the data link layer oversees the delivery of the packet between the two systems on the same network. The network layer ensures that each packet gets from its point of origin to the final destination. Means the delivery of the packet must be defined by the network layer. If two systems are connected in the same link, there is usually no need for a network layer. However, if the two systems are attached to the different networks with the connecting devices between the networks, there is often a need of a network layer to accomplish the source to the destination delivery. Means in the same network PCs does not require the network layer. If the network topology is different, if the network is different, if they are geographically area different, the network layer have come into the picture. Following figure shows the relationship of the network layer to the data link layer and the transport layer. Means a transport layer data come to the network layer and it will be formed in a packets. Then particular packet is given to the data link layer at the sending side. At the receiving side, the reverse procedure is there. The data link data collected from the data link layer. The packet analysis is done at the network layer, and the further procedure to the network layer. So as I already told you that each layer have some fundamentals of dealing with data. Physical layer deals with a bit stream, data link layer deals with frames, and our network layer is dealing with packets. S3 defines the header of the data, and it is our data contents. In the header there will be source address, destination address, and other components. Fine. You can see that the network layer is responsible for delivery of individual packets from the source host to the destination nodes. Fine. It is clearly understandable. So let's define the roles and responsibilities of the network layer. There are two major responsibilities of network layer is logical addressing and routing. One of the important and one of the responsibilities of our OSI layer is logical addressing and routing. The physical addressing implemented by the data link layer handles the addressing problem locally. If the packet passes the network boundary, we need another addressing system to help the distributing the source and destination system. The network layer adds a header to the packet coming from the upper layer. Among the other things include the logical address of the sender, receiver. We will discuss the logical address later in this chapter. Second is routing. When the independent network of links are connected to the create internetwork or network of networks or a large network, the connecting device called as a router or the switch route or switch the packets from their destination. One of the function of the network layer is to provide this mechanism. Means routing means, suppose in our lab network there are 5 labs are there. Lab 1 have a 10 PCs, lab 2 have a 2 PCs, lab 3 have a 4 PCs, and lab 4 is a 9 PCs. If lab 1 wants to communicate with our lab 3, in which path our data can go, it will be decided by routing. In the routing, there are several components used, just like a router, switch. We are also going to see each component in detail in our preceding session. So right now you just understand the routing is a direction provider. You can say that it is a direction provider. Our packet can be directed by the routing at which path they go for a destination address. Yes, this figure shows the source to the destination delivery by the network layer. You can see that it is a hop to hop delivery, fine, and source to destination delivery. As you can see in this figure, we need a source to destination delivery. The network layer at A sends the packet to the network layer B. When the packet arrives at the router B, the router makes the decision based on the final destination F of the packet. As we see in the later chapter, the router B uses the routing table to find the next hop of the router E. Fine. The network layer at the B therefore sends the packet to the network layer E, and the network layer E then it turns sent to the network layer of a F. Means a flow of the data will be in this direction. The router have a particular routing table. We will see in the later chapter, but right now you just understand then if our packet comes at the B end, it have a direction to the E and E have a direction of the F. Means the network layer responsible for delivery of the packets from the source to the destination. Okay, what is the next layer? Yes, transport layer. As the name displays, some transporting. It delivers the data across the network connection like TCP. Different transport protocol may support the range of the optional capabilities, include error recovery, flow control, and retransmission. So let's define the transport layer. The transport layer is responsible for process-to-process delivery of the entire message. A process is an application program running on the host. Means suppose in one PC a particular PDF viewer is running, then in the second or a receiver particular PDF viewer is there. So there is a process. PDF viewer is some process or application program running in the host. Fine. Whereas the network layer oversees the source to the destination delivery of individual packets, it does not recognize any relationship between the packets. Fine. It treats each one independently, as though each piece belongs to the separate messages, whether it does not it. The transport layer, on the other hand, ensures that the whole message arrives intact in order, overseeing both error control and flow control to the source to the destination level. Means in our system, that network layer just transmit the frames or packets. It does not recognize then which packet have a serial number this, which number have a serial number this. But our transport layer arrange these packets in a particular order as our receiver can recognize. Right? Particular figure shows the relationship between the transport layer to the network layer and the session layer. Means data comes from the session layer, a particular procedure occur at the transport layer, and that data given to the network layer. There is a segmentation is occur at this transport layer. As I already told you that each layer have its own mechanism to deal our data. Physical layer deals with bit stream, data link layer deals with frames, network layer deals with packets, and our transport layer deals with segmentations or segments. Fine. Each segment have a header also. So you can say that the transport layer is responsible of delivery of a message from the one process to the another. Let's define the responsibilities of the transport layer as shown over here. First is service point addressing. Computer often runs several programs at the same time. For this reason, the source to the destination delivery means delivery not only from the one computer to the next, but also from the specific running process on the one computer to the specific process running on the another computer. As I already give you an example of PDF viewer, that PDF viewer in the one PC, it is a running application in the one node, and another PC having the same PDF viewer running in the same application program. The transport layer headers must therefore include a type of address called as a service point address or a port address. The network layer gets each packet to the correct computer, and the transport layer gets the entire message to the correct process on the computer. Second, segmentation and reassembly. Segmentation is done at the transmitting side and reassembly done at the receiving side. The message is divided into the transmittable segments, which each segment containing a sequence number. This number enables the transmission layer to reassemble the message correctly upon the arriving at the destination address, and to identify and replace the packets which are lost in the transmission. Fine. Next is connection control. The transport layer can be either connectionless or connection oriented. The connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination machine. In the connection oriented transport layer makes the connection with the transport layer at the destination machine first before delivering the packets. After all the data are transmitted, the connection is terminated. Means in the connection control mechanism, there are two types of connection oriented and connectionless. In the connectionless mechanism, our transport layer just send the data to the receiver or send the segments to the receiver, and receiver deals with that segment. In the connection oriented, the first connection is established, then each segment is transmitted. At the receiving, it will be arranged and assembled, so you can reassembly at the receiving side, and after completion the transmission, the connection is terminated. Next is flow control. Like the data link layer, the transport layer is responsible for flow control. However, the flow control at this layer is performed end to end rather than across a single link. Next is error control. This two type of control also we have seen in our data link layer. In the error control, like in the data link layer, the transport layer is responsible for error control. However, the error control is at this layer is performed process to process rather than across the single link. The sending transport layer makes sure that the entire message arrives at the receiving transport layer without error, just like a damage, loss, or duplication. Error correction is usually achieved through a retransmission. We are going to see the particular protocol for this type of retransmission. Fine. Okay. This figure illustrates the process-to-process delivery by the transport layer. Means some application process run in this PC. That process will be connected through the transport layer from this same process run on the another PC. So transport layer is a process-to-process delivery. Network layer is a host-to-host delivery. Means one PC to the another PC. The transport layer is in advance, process-to-process. Okay. Okay, students. Up to now, we have defined 4 layers of OSI model, and it is a question for you. Write down in your notebook and send back it to me as per the given direction. We will continue our discussion in the next session by defining the remaining layers of OSI model. I hope you understand these fundamentals of OSI layers. Thank you. See you in the next session.